Hi. There's 4 things you need to know about Charlie.
Just 4?
Can you count them up? First, he's the nicest, kindest, sweetest, most wonderful person I've ever met.
Thank you.
Second, Charlie, I think he dropped out of school while still in the womb.
It's true.
He told me that he spent 20 years in the shower working everything out, so we know he's the cleanest researcher. Charlie does things in really amazing ways. You know, he's the kind of guy that if something costs $10, you give him 20, he comes back half an hour later with your change and it's a fish, and he explains why, and he's right. And I think that's a wonderful quality to have. Third thing, when David Johnson started Dakota, David had a wonderful idea. And the first person he went to was Charlie, and he said, all I need is to be able to download the internet in real time and apply every algorithm in the world. And Charlie's response was, okay, I can do that. And the 4th thing you have to know about Charlie is he lives in New Jersey, he travels to Atlanta, and on the way, he knows this place in North Carolina that sells moonshine, and he always brings me a bottle.
South Carolina.
That's cryptic. I think for anybody to have any one of these qualities is amazing, but to have all 4, Charlie Wardell.
Thank you. I have never been introduced that way. But it's all true. My father told me when I was younger, you know, go to college and get a good education or you're going to be a forklift driver. And he was absolutely right. I am a forklift driver, except I move enormous amounts of data. And it's a thankless job, it's a difficult job, and it's getting worse. So basically I'm going to be talking about that today. We'll talk a little bit about the grid that I created, and just going to recap from this morning on David's call. There are, you know, P&G. They're kind of looked at as the, you know, the altar of analytics for marketing and research. Right? They're just amazing. When you go into their facilities and you see how much money they pour into analyzing your usage of a product and videotaping and recording you. And I was talking about an example today where they have this special room. It's actually a house. You walk in to this room and there are cameras hidden all over the place, and they tell you as a panelist, you know, we want you to wash laundry. So you go in there with your laundry and you get paid for this, and they're basically observing you washing your laundry. And you don't know why they're observing you. They just want to watch you open the box. Right? And they're collecting all this data, and it's absolutely amazing. And they pour so much money into this analysis and collection of data. It's really, truly amazing. So when they talk about this continuous innovation and one-on-one relationship, and you know, we need more methodologies, you know, they're really, really driving the way we're actually constructing a lot of our research and a lot of our technology. So I know you know the channels of structured data, right? We have Excel, Access, MySQL, Oracle, DB2, right? We have sales data, human resource data, finance data, point of sale data, transactional data, web trends data, cookie level data. We talked about Microsoft, and I'm going to show you a little video on Microsoft, and I hope you're not going to shoot me. Where is he? You're fine. But it's about marketing, so I think I'm safe. Cookie level data for Microsoft, 12 billion cookies, that's a click, right, per product per year. That's what Microsoft collects at the cookie level data. And I know because I worked with Microsoft cookie level data. They couldn't handle, even Microsoft, one of the largest technology companies in the world, with all the database technology, they could not handle 12 billion records related to a single product. So what they had to do is they had to roll up and summarize that data daily. So they brought 12 billion records down to 365, right? Just think of all the detail you lose because you're not able to handle big data. So your world is radically changing from moving and managing big data to trying to exploit it, right? And I think the focus I'm trying to drive here is that we are at a point where data science is the buzzword in the industry, and exploitation of data, it's got to be where your real focus and mindset is, because everybody's running to the management of that data. And this started happening, I noticed in around 2007. My background is in big data, primarily structured data. I was building some of the world's largest data warehouses back in 2007, but it was relational, right? It was using Teradata and Netezza, those types of technology, and we were in the billions and billions of records. We were doing big data before big data was big data. But they solved this problem, right, in the structured world. Back in 2007, when I was doing industry consulting for data warehousing, 70% of your data warehouse initiatives failed, right? And 60%, up to 60% of your cost was in the integration, because data doesn't come pretty, right? And it doesn't look the same from provider to provider. And this person has a date format like this, and this one has a European date format, and this one has a, it's crazy. So 60% was on an integration. The technologies were overpromised, they performed poorly, and vendors oversimplified the time to implement. And when you were dealing with this large amounts of data, it was, data warehouses were multi-million-dollar engagements that executive sponsorship, substantial executive sponsorship, this last piece, if you didn't have it, your data warehouse failed. Unless it was a top-down initiative within the organization that said, you will build this data warehouse and you will use it, it failed. People wouldn't adopt it. People wouldn't use it. They wouldn't trust it. The data wasn't timely. Today, fast forward, there are tons of technologies that crack that code. The industry has made great strides in structured data, from Teradata to Netezza. I'll show you those. And the analytic tool sets for structured data is widely available. And I'm just going to show you how they crack the code. It's through parallelism, and it works in the same way that parallelism works today in big data. But I'm going to give you just a nickel tour of how they crack the code. So this is my favorite example. This is a Netezza blade. If you ever heard of Netezza, they were the only competitor to Teradata, which, by the way, sells a single database frame, a rack, for $1 million, just a single rack, okay? They were the only competitor that was able to come in at around $500,000, and they took the market by storm. They were their only competitor. They broke the mold in how you process the data. And even at $500,000, it was like people couldn't get enough of it. And here's how they did it. They created what they call this snippet processing unit. It's a SPU, okay? And on that SPU, there is a disk drive. And there is also a dedicated CPU. There's also dedicated memory. And there's a dedicated Ethernet port. It sounds like a computer, doesn't it? It's really small, though, okay? And what they did was they took the hard drive, they divided it in half, and they basically put the data on half the hard drive, and they created another SPU, and they put the neighbor's data on that hard drive to create redundancy. And they took these guys, and they racked them up, 106 of them in a single rack, okay? Now, if I have 1 billion records, and I put record 1 on SPU 1, and record 2 on SPU 2, and record 3 on SPU 3, and I distribute my data paper thinly across all of these blades, now when I do a query against 1 billion records, and I have 100 of these SPUs running, it acts like it's a 10 million record query. So I'm able to query 1 billion records in performance of only 10 million. And I can cascade and I can extend these racks, and there are just enormous infrastructures. Zynga just has enormous infrastructure of these. SBC, Walmart, they have 106 Teradata units to manage their point of sale data. So they cracked the code on structured data, right? But this is what you get with structured data, right? This is a screenshot from the dashboard that we offer. We call this buzz, right? We call this buzz metrics. You can see it's basically the data that you're counting. How many cookie clicks were there, right? What is the percentage that's positive? What is the percentage that's negative? What is the average post per day? How many are male? How many are female? It's called buzz metrics, and it gives you a snapshot, but it doesn't really tell you anything other than the obvious that you can probably deduce from other means, okay? And people have been, up until this point, ignore that, I am not a crook. It's a new laptop, and they have Windows 8 on it, and I uninstalled it, and I put on Windows 7. I'm waiting for my CD. Sorry, I'm not a crook. Okay. Back on track. Okay.
The real world.
All right, so this is the kind of data you get, and up until this point, companies are making decisions with product related to this type of data, right? They're making decisions on buzz metrics. And the reason why everybody has buzz metrics is because they can't analyze data. They can count it. That's what structured databases do. They count. They sum. They average. They don't analyze linguistically. They don't discover things, right? If it has numbers, I can add them up. That's basically it. So I'm going to now show you the result of marketing based on counting. Can you hear that?
TV experience. TV. TV and movies. TV. Xbox. Watch TV. 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 Watch TV. TV. TV and TV remote. TV experience. TV. 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 Sports TV. TV. TV.
So let me put a little context on this. My son, he says, my son's a big gamer, and he's in college, and he sends me a text message because that's the only way they communicate now. They send you a text message, and he says, OMG, did you see the Xbox launch? And I'm like, no way, what was it? He goes, you got to check it out. And I'm like, all right, check it out. And I said, OMG, LMAFO, you know, and he's like, yeah, WTF. Essentially, this goes on and on and on about TV, TV, TV. It goes on and on about Halo, 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 right? And then COD, COD, COD. And it's just a regurgitation. It's a 2-minute video. I'm going to spare you it. But that's what happens when you analyze survey data and you find out what people want in their next experience. And there's a checkbox that says, you know, better graphics, interaction with my TV. And they just do this checkbox. And when you get a count that's overwhelming, I want a full television experience, I want it embedded in my television, you get the lockstep about TV being the #1 driver in their marketing. When if you analyze the data, which I did, if you take the raw text of the data, you will find out that the people playing these games want Xbox not to scratch their CDs. They don't want it to overheat, and they don't want it to just randomly malfunction. That's the drivers that they want. This is the driver that they're selling, and this is based on essentially survey data. Okay, so I digress. So our clients want to know more, right? So structured data is falling short of answering questions. They want to know, you know, tell me something I don't know. Discover something, right? Where's my white space? White space, you know, what's the next product I can launch? Who are my biggest threats? What are my biggest threats? Right? The basic questions that executives want to know that enter them into the next market space, right? They don't want counts, how many clicks person came to my website had. That is so 2007, right? So the channels of unstructured data, right? Books, journals, documents, analog signals. Analog signals. You know that IBM has talked about this radio telescope that's going to be basically turned on very soon, and within a few years is going to be collecting an exabyte of data per day. Wow. How are we going to analyze that? Call center data. You know, a single Fortune 50 company can have 50 to 100,000 customer interactions in a single day. That's a lot of data. Okay. Images, video, audio, transcripts, email, blog, tweets, consumer comments. Now, Dakota, we're trying to get under the hood of the data. We're trying to get out of the counts. We're never going to get out of the counts completely, but we want to expose some of the insights, and we're starting to do that with emotions, right? You can see anger, bitterness, confusion, disappointment, disgust. This is just a sample of things we're teasing out of the content. This doesn't mention things like wow scores. Like there's an element of wow in those documents. It doesn't mention things like mental model changes, which is something Phil has been working on recently, where someone had an epiphany and said, holy smokes, right? So we're actually getting in at the textual level, but it's challenging, as some of you know, and some of the benchmarks I've been hearing, where it takes you 16 hours to process a very small set of data, or it takes 23,000 minutes to do a clustering, right? It's just an enormous problem that we're personally trying to conquer. So the whole world now is moving to management. In the structured data revolution, you had Teradata and Netezza, Vertica, Exadata, DB2. But today, there's a new arms race with big data and NoSQL style databases, right? Hadoop. I know you all heard that word. HVC, HBase, Voldemort, Cassandra. It's like, in 1849, everybody ran out west to mine for gold, and the only people making money were the ones selling the pickaxes and the shovels, right? It's kind of what's happening right now, right? Everybody's in the money. I mean, David and I go out it all the time. We're out in the market and we hear big data, big data, big data, and there's money readily available with big data. We made a decision not to be a big data vendor because very early on, we said that people buy people buy answers, right? People buy answers, not technology. But in order to do our work, we needed to become a big data competency, right? So big data is a big problem. But the exploitation of it is where the money slide. Exploiting the big data, not moving it or managing it or being a forklift operator like I am moving this data. Although, as data scientists, if you're entering into that field, you need to know it, right? It's not a glamorous job. Tool vendors are focused on the management of the data. The skill set for management and exploitation are radically different. I can't do what you guys do, but I can move the data, right? You are focused on exploitation, but the science is in the exploitation. So where does Dakota fit in? So this was actually cut off. Okay. So synthesizing big data, we have all of these data sources, and we're doing your traditional extraction, your transformation, and we're creating this validated data set. Now, when we have this validated data set, we have this thing called a model shop, right? And that's where all our emotional models are. And we run this data, this validated data in our grid, and we create what we call enriched data. That enriched data, that validated enriched data is sorted, it's joined, it's prepared for loading into production. So we go from disparate data, we unify it, and then we go back to disparate data, because a tweet is not a blog, and a blog is not a news article, and a news article is not a board post, right? So we need to have that separation in our data. But the data is enormous. The volumes that are coming in per second, it's just terabytes and terabytes of data. So we have this grid. So we have this data that's flowing in various ways. We have real-time data flowing in. We have batch data processes flowing in, where you can actually land your data, but the grid can process it one and the same. Okay? And what makes our grid unique is that we have our Dakota developed analytics. And these things operate as plugins. And then we have community developed plugins, where folks like you can actually develop a plugin and sit it in our grid. And as a customer utilizes the data flow through our system, they can choose which plugin they want to run on that data in real time. So essentially what we've done is we've taken away all of the forklift driving aspect out of the industry, and we're basically saying, focus on the analytics, focus on the science, put it in the plugin, let us move the data through, and we'll let your algorithms run on top of that. So at a high level view, We have all of these disparate data feeds. You don't have to worry about acquiring data. We have boards, blogs, tweets, Facebook. We have consumer comments. It's all flowing in. And then we have this collection of plugins that run on that data and create incredible insights that our customers look at these wonderful dashboards that have things that are far better than just counts, right? It's just so much, it's such a rich experience. So, some of the plugins that we have are doing entity identification. Some of these plugins, we're detecting emotion. Some of these plugins are doing some gender detection even, right? So now that we have all this data as it's streaming in and it's marked up, imagine how we can change the world in search. Today you go on Google and you type in, show me everything about the Xbox, and you get results back. Or a brand manager goes in and says, well, show me anything that mentions Coke or Pepsi or 7-Up and an executive named John Scovey. Okay, and you hope you get back the results that you're looking for. But imagine saying to the same search engine, return to me any mentions of a beverage. And the post also must contain the name of an executive, and the primary emotion has to be anger, and the post had to be created from the Southeast. You're not mentioning what the beverage is, you're not mentioning who the executive is, and you're not mentioning the region in the Southeast, but the system is smart enough to know exactly what the beverage market means. Or all the posts where the author is male and is excited about golf, drives a luxury car, and mentions a telecommunications brand. See, because we're streaming in the data and we're able to tag the data in real time, because we're kind of cracking the code of big data, we're opening up the world to a whole new kind of search that is extremely relevant for brand marketers, right? They don't have to create ridiculous Boolean logic for a query of, Pepsi or Coke or Diet Coke or Diet 7-Up or Mountain Dew. They don't have to define the beverage market. We've done it for them. Okay, so essentially there's a call for help. What we're talking about is technology doesn't sell as well as results sell, right? So we need the community to start developing intellectual property, and you need to run your intellectual property on big data. So we think there's a peanut butter and jelly thing happening here. We want to open up our grid to you, right? And we want to allow you to use it. I want you to focus on where the science is. We'll focus on the data and the movement of the data. We have the data, the grid, the horsepower. Do you have the science? That's basically it. So if you have a way of detecting gender out of free text, and you want to put it in a plugin, and it has an 80% accuracy rate, or if you have a way of detecting language, or if you have a way of doing something incredible. I'm agnostic as far as the method. I would like 5 gender detector plugins created by 5 different people and allow my client to choose the one he wants to use for his dashboards. Right? To me, I'm just moving data through, and I'm opening up a platform by which we can really extend through some real good science. That's it. Questions?
Ask away.
Can you talk about the plugin architecture? I mean, how do you get started?
Good question. So the question is a little bit about the architecture. So I promised I wouldn't get too geeky because I can really do that easily. Years ago, when we had processors being developed, there was a single processor, and what they did to improve performance was they made the processor faster. Okay? Today, what they're doing is they've reached a limit as far as your processors can go. So what they're doing is they're making cores within a processor. So a single processor would have 4 or 8 processors in it. But the languages that were written yesterday aren't exploiting the multi-core nature of these newer chips. Okay? So all of the technology that you've seen 2007-ish, until recently, have all been thread-based architectures running on a single core. So what we did very early on is we looked for the best languages for concurrency. Okay, there are only a few of them out there. Erlang is one of them, created in the 1960s. Clojure, a Lisp-based language that runs on top of the Java virtual machine, and Scala, okay, which runs on top of the Java virtual machine functional language. And we're actually using a bunch of all of them. We're using all of them. So when our CPU utilization, it's like even 98% across all our cores. So we get awesome utilization. The second thing is that in a threaded architecture, threads block. When I tell this thread to do something, he does it until he's finished, and then he'll release the thread. Now, one of his tasks may be to write data to disk, and he may be doing nothing at all during that write operation. So he's just wasting time waiting for acknowledgement that the data has been written. So there's a complete waste of time with this thread. These new modern concurrency-oriented languages are event-based. So I will write to disk, and I will hand off the baton to the next actor who will do this work. So it's very efficient in big data. So our architecture is basically a divide and conquer architecture across many nodes. We can have unlimited nodes. We don't have a master head node like Hadoop. So we can have thousands of nodes. And as the work streams in, it gets farmed off to any one of these nodes. Part of the data, or surrounding the data, is the definition of what needs to be done. The definition of what needs to be done is not hard-coded in the grid. It's sent as a message to the grid. So the grid is purely utilitarian. It just operates as a utility. You tell it what to do with the piece of data that you're giving it. Now, what you tell it to do can also be parallelized. So even the tasks at the task level are parallelized. So that's basically the highest level view without going into.
Charlie, well, his question was, how do you actually start by creating a plugin?
Yeah. So it runs on the Java virtual machine. There is skeleton code that is literally 15 lines long that is the code to create a plugin. If you can write in Java, you can create a plugin. Everything is there. We have a special placeholder for you to put your logic. What you will receive is an object model, which includes the data, and then you have your plugin. We give you the method call to access that data. You do your work, and then you do a method call to export your data. It's literally 15 lines of code that will give you a plugin. Your logic could be hundreds of pages, granted, but our plugin, all is required from us to be a plugin, about 15 lines of code.
So you basically supply the framework, taking care of all the plumbing and stuff, and you're just looking for the actual algorithm implementation.
That's right. That's exactly it.
So, if I understand correctly, then means that Dakota is not dealing with the search engine itself. Like the example you said, give me all this, calls mentioning the beverage.
We're getting all data. So when our customers are applying search, we're searching our own database. So Phil was kind of right. We're kind of replicating the internet. No, we're not replicating the whole internet, just what's relevant, right? Posts, tweets, blogs.
Right. So you're also doing the search.
We're also doing the
right.
search.
When you do the search, you will need a knowledge structure about it so that you know that what beverage is. So it means you have a parallel ontology-like structure, right? That
That's
you mungus about.
That's what we do. Yes.
Okay.
So we do have, as data streaming in, we have this frame-based approach and these models that actually define the beveraginess of the document as it streams in, and we tag it. This is a beverage candidate document, and that intellectual, there are people that are experts in the automotive industry, and they can define that. And as data streaming in, we will score it according to that model for automotiveness. And if it receives a high automotiveness score, you can assume that it's an automotive-related document.
Okay, so here's my question now. That was preconditions. So do you have plugins as well for that ontology structure? So because if I'm building the search engine as a plugin, I should need also probably merging.
That's an excellent question. So the question is, so dictionaries, how does that work, right? Or files I need to read at startup for my plugin. We have the concept of persistent plugins. where plugins load once in memory and they stay in memory, and they can either access a hash table or memory loaded at startup time, or they can access a file on disk. And if you provided that file, our plugins access, read these. We have hundreds of these files, and at startup time, they're all read into memory. They stay resident in memory. So you would supply that as well with your plugin. Any question?
Yeah. So when you're building these plugins, like say you're doing a sentiment, building a sentiment model or something for classification, like you're going to need the data in the first place. So is there a way for the API, like for your plugin API, to get the data to build the models and then use it then? Because if you don't have the data, how are you going to test the model or see how it goes?
Yes. So we have a dashboard application that allows you to query the data, pull it in. You can see the buzz metrics aspects of it. In our market, you can see the emotional aspects of it. And then there's also a way to export that data. So yes, you can export a sample set of that data, fine-tune your algorithms and say, you know, Eureka, I have a plugin, put it in, and now let's run it on a full test bed of data in the tune of millions of documents a day. Yeah.
Who is your competitor?
So we are not competing in the big data market per se, but if you were to look at our platform from a big data perspective, we're kind of the real-time version of Hadoop. So we're more into the analytics side, right? So David, who would you consider our #1 competitor today from that perspective?
There are certain things I really despise in our industry because of the generalizations that are made. So I don't like the term big data, hate the term sentiment analysis as well. We would fall into the sentiment analysis category, and that would range from everybody doing thumbs up and thumbs down analysis to more refined analysis like us, to real hands-on, handcrafted, small sample size, projected analysis. So we would fall into this in the sentiment analysis category. And we'd be in the big data category too, because we handle lots of data. We basically create, for all our clients, we create a virtual big data platform in the sky. But in our world, we never want to go and actually sell that to people. Because as soon as you go into an organization, you sell that, you're going to start talking to the IT organization, and you get into all these debates. And the people that we work with, like our brand customers, they don't really care about the technology. Like Charlie said, they're looking for answers. And so we just say, hey, we'll just bring the data to one central location, analyze it, and then we'll present it to you. So we would fall into, yes, the big data space, and yes, the sentiment analysis space. So when we look at competitors, on the big data side, I don't really see any real significant competitors there because we aren't really kind of in the pure big data play space. But the traditional sentiment analysis vendors would include companies like Radian6, Sysomos, Clarabridge, Crimson Hexagon, Harvard, a number of companies like that would be considered. Those are the companies that we've replaced as well at the companies that I mentioned this morning.
Yes.
You stress the importance of computational efficiency. There's another community which cannot compromise when it comes to computational efficiency, and that's the high-performance computing community. They have parallel languages and they have tools that provide services, such as Globus, and then the languages of Silk and pthreads and OpenCL. You have chosen to sacrifice some level of performance in order to use different tools. Why did you make that decision?
Yeah, that's an excellent question. So the question is, in the high-performance compute industry, there are very specialized libraries and tools, and when you're specialized, right, you're efficient. When you're generic or utilitarian, you're not, right? So it's an excellent question. My focus on building this grid was to give you the tools so that you can do what you want. As a matter of fact, one of the plugins that we're developing is actually a GPU plugin, so that we can have the plugin actually interpret CUDA, right? So that in the high performance community, so what we're doing is we're doing the plumbing of moving the data, and that algorithm can run in a GPU. So that plugin can strictly use a GPU. MPI is another one, or JMPI. So your plugin can actually inherit the library of this message passing interface, CLib, and then you can actually, when you hand it off that plugin, you get loop level parallelization, right? So you're not getting message-based parallelization across the grid. You're getting loop level parallelization within your plugin. Follow? So we kind of leave it up to you. For our purposes, we wanted to create a generic utility, but you're absolutely right. When you're generic, you do sacrifice optimization and performance.
I think we can stop there and thank everyone for coming to the session and thank